As we begin applying trigonometry, what we're going to do is we need to make sure that we are comfortable with SOHCAHTOA and understanding the ratios, sine, cosine, tangent. So being able to relate sine is the opposite over the hypotenuse. So the sides of my triangle in reference to my angles. So the opposite side over the hypotenuse. Cosine is the adjacent side of my triangle over the hypotenuse, and then the tangent ratio is the opposite over the adjacent. So being comfortable with those and understanding, how they align, looking at applying it to a basic triangle, basic right triangle, that if I am talking about angle A, that this side over here is my opposite side. This side is the not adjacent, but adjacent side, and this side is my hypotenuse, which is always across from the right angle. So these are the kind of things that you need to be comfortable with. Now, when we start applying trigonometry, we just need to understand some things that in reference to that as we're talking about the words. But the first thing they sort of talk about is the angle of elevation and angle of depression. So as a person, in this case, we'll look at this example, as a person looks up, you are elevating your eyes upwards, so that would be an angle of elevation, versus if I was standing at the top of a cliff, and I was looking down, that would be the angle of depression. Okay, so down, depression, up, elevation. And then understanding what does that mean if you consider your horizon. They always want to talk about my horizon is going to be, this flat line. You have your ground, which is considered ideally a flat line. So your horizon and the ground is going to be parallel. Seems sort of unusual I did that backwards, huh? But your horizon and your ground is going to be parallel lines. And then so my angle of depression is this portion right here as I look downwards. So that is my angle of depression. My angle of elevation is as I look upward, which is this one is my angle of elevation. So what they're trying to tell you here, if we have two parallel lines cut by a transversal, these would be alternate interior angles, so these angles are actually congruent. So when I'm thinking about the angle of depression or the angle of elevation, it's going to be the same measurement. And then just being able to apply that along the way. So here, looking in this first example, Rakeem is flying his drone at the park, and he stops the drone at an angle of elevation that he estimates is 30 degrees. Again, from his level eyesight across the horizon, we went up 30 degrees. And the remote control tells Rakeem that the drone is 102 feet away. 102 feet above the ground. So that is taken into account that not only, we have this height, we have to consider that, but the total height from the ground up, this would be my horizontal height from Rakeem's eyes, is going to be 102 feet. And if Rakeem is 6 feet tall, ideally, this is 6 feet tall, how far is he from the drone to the nearest foot? So how far is he? We are looking, I'm assuming, we are trying to calculate the hypotenuse right here, because that is the direct route to the drone. And knowing that if I wanted to create that right triangle, here is my right triangle, and I'm looking from the horizon here, the horizon of my eyesight upward, and then what is this height right here? So I have an angle measurement, and this is going to actually, this side of this triangle is going to be 102 minus 6. So that should be, 96 feet. So now then looking at that, the sine, I have two ratios here. The ratio I can use the opposite over the hypotenuse. So the sine of 30 degrees is going to be the opposite over the hypotenuse. And so the sine of 30 degrees is going to be the opposite over the hypotenuse. And then to get my variable in the numerator, I have to multiply x both sides, or it may also appear to be cross multiplying, and I get x, the sine of 30 degrees is equal to 96, and then I'm going to divide the sine of 30 degrees away because I want to get x by itself, and then that is how x becomes this. So just plugging that into the calculator finds me a value. Okay, so using the calculator, I did 96 divided by the sine of 30, which is going to be 192, which means that Rakim is 192 feet away from the drone. Now, I'm going to introduce a alternate method here, because sometimes moving this sine of 30 degrees and this manipulating of a variable number, those kind of things get a little bit complicated. So if I just come right here and I begin back here at the sine of 30 degrees is equal to 96 divided by x. Well, what I can do is I just went ahead and plugged in the sine of 30 degrees is actually just 0.5. So I went ahead and substituted right off the bat 0.5. Okay, 0.5 sine of 30 degrees is 0.5 is now equal to 96 divided by x. And some students are more comfortable with this. I just have some numbers over here, and I can do the cross multiplying. Okay, so 0.5 times x is 0.5x, and that is equal to 96, 1 times 96. And then I just go ahead and divide by 0.5, and x is going to be equal to 96 divided by 0.5, which is 192. Doing this substitution, I've determined, or I have had some students more successful here. If they go ahead and just say, hey, sine of 30 is 0.5, and then go from there. And then it's a little bit easier for the students to manipulate just these numbers instead of worrying about this. This is nothing more than a different way to represent 0.5. So that is an option. So I will sometimes do it that way just to show that it can be a little bit clearer to understand. Now, it says check, search and rescue, great. I would use this always to say that anytime you're doing a trig problem, trigonometry, go ahead and just draw your triangle. We know we're dealing with a right triangle, and then just fill in the blanks of the information that you know, and then proceed with that. So I would encourage you to give this a shot on your own, stop the video, and then I will go on and do it and explain it so you can check your answer. Okay, so looking at this, it says that a flare is shot vertically into the air approximately 200 meters from base camp. So if this is my base camp, let me go ahead and just say this is my base camp right here. I'm camping out in my tent. Got a little fire out there, smoke. So there's my base camp, and the flare went up 200 meters away from my base camp. So that would be how far am I from the ground. And then it says the angle of elevation to the maximum height of the flare is 35 degrees. So from here is my angle of elevation as I look up to the flare is 35 degrees right here, this space right here. And it says the group at base camp needs to know the altitude of the flare. Well, the altitude is going to be the height right here. So the height is going to be x. So things that I have in reference to my base camp, I do have an angle measurement, okay? So it doesn't matter, something 35 degrees, right? I have 35 degrees, don't sure yet. This is going to be the opposite side of my, the opposite side of my triangle, in this case, the opposite side. And this would be the adjacent side, and this would have been my hypotenuse. So if I'm trying to figure out the opposite side, that would be, I could use either sine or I could use tangent. And in this case, the hypotenuse, I don't know what the hypotenuse is. So it wouldn't do me any good to use sine because I don't know what the opposite or the hypotenuse is. So that's why I would eliminate using that one. But I do know that the tangent now of 35 degrees should be equal to the opposite side over the adjacent side, which I know is 200. Okay. So there you go. We could, now this might be a little bit easier. This is one of those where we don't have to move a lot of numbers. And it says, what's the maximum height? Well, the maximum height is x. So if I multiply both sides by 200, I now know that x is equal to 200 times the tangent of 35 degrees. And plug that in the calculator. So plugging that in, you know, again, the 200 times the tangent of 35 is 140.04, and it does say round to the nearest meter, so the height is going to be approximately 140 meters. Now, looking at that, I did go ahead and simplify this, where I made a comment before that sometimes it's easier to take tangent of 35 and just make it a decimal. The calculator will tell you the tangent of 35 degrees is 0.7002. Now we have what looks to be the cross product property, so I can say 200 times 0.7002 is equal to 1 times x, or x is equal to 140.04. So either way, I'm going to get the same information. So again, this is sometimes a lot easier to follow. Okay, so with that, moving on, looking at the angle of depression. Let's see, the Cottonwood, Idaho's Dog Bark Park Inn, is a popular tourist attraction featuring a hotel in the shape of a 30-foot wooden carved dog, beagle. Pedro looks out the window 30 feet from the ground and spots a fire hydrant on the ground at an estimated angle of depression of 40 degrees. What is the horizontal distance from Pedro to the hydrant? Okay. So again, he looks down from a 30-foot height. Angle of depression is 40. We are trying to figure out how far is he from the horizontal distance from the fire hydrant. We know that the angle of depression is the same thing as the angle of elevation. So we are looking at this triangle now. Same difference if we just drew a triangle here. We have 30 feet height. We have an angle of elevation of 40 degrees, and we are trying to figure out how far we are from that. So again, we have the opposite from our angle and the adjacent to our angle. So that's what they're coming up with, that information. And they tell us that is the tangent here. So the tangent of 40 degrees is going to be the opposite over the hypotenuse. Simple enough. And they did some cross product property here, and they said that x times the tangent of 40 degrees is going to be equal to 30, and then divided both sides by the tangent of 40 degrees. Tangent of 40 degrees divided by the tangent of 40 degrees. And so 30 is, x is equal to 30 divided by the tangent of 40 degrees, or approximately. So putting that into the calculator, we find out that 30 divided by the tangent 40 degrees is 35.7526. If we would have converted tangent of 40 into a decimal right off the bat, we would have had 0.8391 over 1 is equal to 30 divided by x. You cross multiply, and x times 0.8391 is equal to 1 times 30. Divide both sides by 0.8391 divided by 0.8391, and we find out that x is equal to 35.75. Okay, so either way we're going to get the same answer. It says, what is the horizontal distance? It is about 35.75 feet. Some people might have said it is about 36 feet. 36 feet, because maybe you rounded up automatically. That's great. If you said, however, 35 feet, that is incorrect, because you would have rounded in the wrong direction. Okay, that you would have done it improperly, so the 7 would have rounded up to a 6, so that's why you could have said 36 feet, but it just depends on what the answer is asking for. Lifeguard. Okay, now this problem again, just create, I would stop it here, try it on your own, but create your right triangle, and then fill in the information, and then go with it from there. Braylon stands on a 8-foot platform. Well, okay, so right now he is standing right here. And sights a swimmer at an angle of depression of 5 feet. All right, so see, I have this because I'm going all the way up. He sights it at an angle of depression of 5 degrees, and he is 6 feet tall. So this entire length right here is 14. How far away is the swimmer from the base of the platform? All right. So again, this triangle looks something like this. I have 5 degrees. I know that he is 14 feet up in the air, and I am trying to figure out just how far is he from the base of the platform. So that is, again, going to be the opposite over the adjacent, which happens to be tangent. So the tangent of 5 degrees is going to be equal to the opposite, which is 14 over x. And then solving that, again, you have the tangent of 5 degrees times x is equal to 14, dividing by the tangent of 5 degrees. Oops. And x is going to be equal to approximately 160. Let's see here. We're talking about feet, so he is going to be about 160 feet away, 0.0207 to be exact, or a little bit more precise, rounding up to 160 feet. So there you go. Being able to do those basic number manipulations. Now, you have a little bit more gamesmanship here to figure out, but let's just see. We is estimating the height of the second floor in a mall. She sights the second floor at a 10-degree angle of elevation. Then she steps forward 50 feet, so she's 50 feet. And then until she is 5.5 feet away from the mall, 5.5 feet away from the wall, sorry, and sights the second floor again. All right. If Wee's line of sight is 66 inches above the ground, okay, 66 inches above the ground, at what angle of elevation does she sight the second floor? Okay, so looking at this, let's just think about what information we do know. And I'm going to draw more of a triangle over here so I can start calculating some stuff. X. How can I calculate x? Well, first of all, x is in feet. She is measuring her height in inches, or she. So 66 inches is actually 5.5 feet. Okay, so that's something we need to know. That 66 inches is equal to, let's see here, 12 inches per foot, multiplying across, and we find out that that is 5.5 feet. All right, so that's something we need to know. So this height right here, if we need it, is actually 5.5 feet. Let's see, what else do we know? Let's just draw this big triangle. Here's the big triangle. This is B, this is A, this is D, this is 10 degrees at my right angle. I'm not sure what x is yet, but I do know the entire length of BD is going to be 50 plus 5.5, or 55.5. Okay, so if I want to find out what x is, that is my opposite. This is my adjacent, so I could find out that the tangent of 10 degrees is equal to the opposite over the adjacent, which in this case is 55.5 degrees. So multiplying both sides by 55.5 feet, multiplying both sides by 55.5 feet, and then x is going to be equal to the tangent of is going to be equal to 55.5 times the tangent of 10 degrees, which x is then going to be equal to. It turns out that it's equal to approximately 9.786, so x is approximately equal to 9.8. Okay, so we were actually able to find that 9.8 height. Now, if I want to figure out what is my angle of elevation, well, taking that little triangle now, I have this little triangle, and I know that this is my right angle, this is y, and I have 9.8 and I have 5.5, so that would be the opposite and the adjacent. And to find y, that would be, again, the inverse tangent now, because I'm looking for an angle measurement, is equal to 9.8 divided by 5.5, and that equals, so we're able to figure that information out. Let's see, where is that? Have they got that one for us? The tangent of y is, again, 9.8 divided by 5.5. And it looks like when you put it in the calculator, it comes to about 60.697. We could say then it is approximately 60.7 degrees. And that's, sure enough, that's what they got there. So being able to look at that and, just draw those right angles, sort of like ignore the stuff around it except for what is useful to you. And then, just sort of filling in the blanks and seeing what is left over and then solving from there, okay? So there's that. It's going to be it, but we could do this sightseeing real quick. So read this over, give it a shot, and I'll put the answer in the margins. All right, so looking at this problem, it's a little bit hard to interpret sometimes. So looking north, 2 skyscrapers are sighted from the viewing deck of the Empire State Building. Okay, 125 feet up. One skyscraper is sighted at 20 degrees angle depression. The second skyscraper is sighted at 30 degrees angle of depression. How far apart are the 2 skyscrapers? All right, so we don't know if the 2 skyscrapers are the same height, so we're just going to sort of wing this. So here's my Empire State Building here in the middle. As I'm looking north, I know that the angle of depression for one is 20 degrees. I'm assuming this is 1,250 feet, so there's my triangle. So I'm trying to find out x. Then the next triangle is going to be like that. Oh, sorry, that doesn't make any sense, does it? The closest one would have been at the slighter degree, right? So the angle of depression is 20 degrees, which is going to be 20 degrees. The angle of depression for this one would have been 30 degrees, so that would be 30 degrees. So we're trying to figure out how far apart are they. So looking at, I have 2 triangles, 2 right triangles to choose from or to work with, sorry. I have this right triangle, which is 30 degrees, and I'm trying to figure this value out, 1,250. And then I have this other triangle that I'm working with, and I have 20 degrees, and I'm trying to figure out ultimately what would be this value, and again, 1,250, so I might be able to figure that out. So what happens is if I can figure out the entire length, right, the entire length distance, and I subtract the closer building's distance, then I can figure out how those 2 buildings are apart. So I'm just going to do these independently and figure out what x and y are and then come back to that. All right, so doing those independently, it turns out that the distance that the one building is 2,165, and I'm just going to say 200, round it up to 2,165 distance, and the other building is going to be 3,434 feet away. So looking at that, I mean, now I can figure out how far apart are these 2 buildings. Again, if this building is 3,434 feet away, this building is 2,165 feet away. Well, this value right here is going to be You know, 3,434 minus 2,165, and that is going to equal 1,269. So that is how far those 2 buildings are away. 1,269. Woohoo! Solid grade level question there. So just being able to look at that, calculating the distance, of course, knowing that one is a little bit farther away than the other one. So if I can calculate the distance of each one of those, then I can figure out what is the difference in those two distances. So that is it. That's what we're doing when it comes to applying trigonometry. When in doubt, make sure you know your SOHCAHTOA. You know, SOHCAHTOA, sine is the opposite over the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, tangent is the opposite over the adjacent, and then just making sure that we create a right triangle and fill in the information we know, and then figure out which ratio works the best for us. So there you go, and good luck. I think